Thank you, thank you, thank you. Thank you for that. Completely unnecessary. I just walked from there to here. But thanks anyway. So, as this part of the slide says, my name is Steve. I am a geek. And hopefully, if we're in the right room, this talk is Ada99, rewriting the very first program. So, over the course of the next 25 minutes, I'll go through who I am and why I deserve to be on the stage. What is Ada99? I'll show you some code. And then I'll tell you what I've learned by this little project. So, who am I? Or as it should be called, the ego slide. I'm a developer and have been since 1983. I've worked on various games on various platforms. I've done the EdTech thing, the JavaScript thing, the assembly programming thing. I advocate open source, VR, and anything else that takes my fancy at the time. Most people say I'm unemployed. I'm actually unemployable, which is why I have all the time to do all this sort of stuff. But according to the City.js website, I'm all of these things. But people only look at the bottom one. And they just say, really, do you get paid money to drink beer? And I say, yes, I do. But unfortunately, I'm not here to talk about beer. I'm talking about development, precisely Ada99, which is a little fun thing I started just as a side project. So a few years ago, it was the 200th anniversary of Ada Lovelace, who created the very first program, which is shown here. This is in Appendix F, and this calculates Bernoulli numbers, which I'm pretty sure you all noticed. And this was the very first program, and I thought, an interesting sequence of numbers. I'm not a mathematician, so I don't really understand what all the cleverness is, but it's a sequence of numbers that could have been programmed on the very first machine. Therefore, it's probably possible to do it in JavaScript. Spoiler alert, it is possible to do it in JavaScript. So instead of using the algorithm that Ada used, which is rather boring, it's only about adding two to numbers and subtracting 2. It's not an interesting algorithm. I found this Akiyama Tawagawa, I think, algorithm, where it's basically you have a series of fractions in a Pascal triangle arrangement, and you subtract one from the other one. As a consequence, you produce the Bernoulli numbers along the left edge. You'll also notice they alternate with zeros. That is not a bug. That's part of the number system. So I thought, okay, I can implement this. Fractions, not too difficult. I can code this. So I wrote it in JavaScript. Yes, that's JavaScript, not Perl. You can write bad Perl in any language, including JavaScript, and I wrote this. Although, obviously, I didn't write that. I wrote it properly, like this. But it's the same thing. So as a brief breakdown of the algorithm, it's not important that you sort of follow along, really. But you're dealing with fractions, so I just said I'll have 2 arrays for the top bit of the fraction and the bottom bit. In order to do the maths calculation, which is subtract 1 and then multiply by the constant, you end up having to do what they teach you in maths class about multiplying the top by the same thing as you multiply the bottom and all this malarkey. So I implemented it. It took part of a lunch hour. You have to reduce the equations, so if you've got 2 over 4, you've got to reduce it down to 1 over 2, because otherwise the numbers get too big and the accuracy of the numbers falls apart. So you've got to do a whole function called reduce, which is the only time I got to use recursion in this little project. And there you have it. That's what it looks like. And, well, that's what I actually tweeted, because that fits in a tweet. That doesn't. So I tweeted this out, and, I got my little dopamine fix for the day. I'm rather proud of myself. And then my mate Bob comes along and says, you've done it in JavaScript. Why don't you do it in Ada? Ada is a programming language. It's something the DoD use for a lot of their military stuff. It's very precise. It's very official type of language. And I thought, well, I don't programming in Ada, but I've got another half of a lunch hour free. So I learned Ada, and I wrote this. It's probably not very good Ada. In fact, I'm pretty sure it's definitely not very good Ada. But it worked. I thought, it's kind of interesting. I've learned a little bit of a language. I looked at some of the things that the language did. You can see it's got formal begin and end blocks and declare blocks, which are separate from the code blocks. I thought, okay, interesting, fair enough. So a little bit about Ada just as an interlude. 1980. I'm pretty sure there's only a few of us who were actually born in 1980, let alone were programming in 1980. But it existed, but I've seen years ago, and it's got very nice strict typing, so your TypeScript fans will like this one. You have to put semicolons at the end of lines, like you should be doing anyway. Oh, so that's the one that divides the room. You've got the double dot ellipses in the language, just like Ruby had 30 years later. Really nice, very handy thing to have. A separate declaration section for your variables so you don't suddenly get hoisted upon. That's good. And they use these weird type of brackets that are rounded. That was strange. And assignment was colon equals, which I thought was really quite handy. It's not the only language to do it. But the keyboard that most of us are probably using has got about 20 different symbols on it. But mathematically speaking, there's about 100 different maths type of symbols, operations, and things that we actually want to do, which means every single symbol is going to probably have 2 characters at least. And as soon as you've got 2 characters, you've got the chance of getting one of them wrong. Anyone that comes from a C background remember the problem of getting a double equals rather than a single equals. This was a problem so far back that people started putting things in compilers that would say, you've done a single equals a value. I think you should write it the other way round. So you'd write 4 equals A, so the assignment would fail at the compile level. They solved the problem by actually changing the symbol for assign to something that you would never confuse. And they used slash equals instead of not equals, which I thought was weird. But it didn't matter. I didn't want to become an Ada programmer, so I can moan about Ada all I like, because they're not going to hire me. And that was the end of the story. I'd written this very first program in 2 languages, I'd got my tweets, I got my dopamine fix, and it was coming up to the end of the lunch hour, so I thought, oh, I can go back to doing some proper work. Well, whatever proper work is. And then I thought, maybe not. You know there was more, right? You didn't think that was the actual end of the talk. No, jolly good. So I was having a little mindless think, and it's like, well, I've done it in 2 languages. How many have I actually coded in? Well, professionally speaking, all these, and then a couple more. Bear in mind, coming from a games background, games consoles, you end up doing assembler. It's one of the few jobs you actually get to properly hit the metal. And I'd done a few languages for fun. Assembler for fun. Oh yeah, 6502. And I've invented a few languages of my own for various things, so I'm contractually obliged to do those. And I've also, not on here, I've done things like brain fudge and other esoteric languages, because I think they're great fun. Again, nothing useful, just good fun to do. So I thought, I've done an awful lot of languages. I wonder how many of these I could actually use to implement that very first algorithm. So I set about doing it in no order, without preference, and I wasn't trying to be idiomatic. I wasn't trying to learn the language by using this as a jumping off point or, well, I know the algorithm, therefore I've just got to learn the structure and the syntax of the language. I'm just interested in doing it. So I did, and I did it in Pascal. Oh, Pascal, how I've missed you. I hope those groans are for the 2 people that got the joke. And this 3-column monstrosity is what's necessary in Pascal to do exactly the same thing as you saw on half a slide earlier. So it is quite verbose, but it is meant as a teaching language, although I'm not convinced anyone that was taught this as their first language would be encouraged to stay with programming after doing this. But, you know, what do I know? So what did I notice? Stupidly verbose, but who cares? A very important declare before use, which comes up quite a lot. Loops need down to. So if you're doing a loop that goes from 1 to 10, it goes from 1 to 10. But if it has to go from 10 to 1, you have to say, I want this to go down to 1. Which is a nice way of reading it, but if these values are not 1 and 10, but x and y, you can't code it. You've got to explicitly work out if x is going to be greater than y, and loop accordingly, or change the way you do your loop constructs. There is a separate instructions for integer and double or floating point division. I thought that was quite amusing. Functions and procedures have different names, and for loops are inclusive. What for loops are inclusive? So if I go from 1 to 10, I'm actually going from 1 to 10 inclusive. This was a teaching language using a practice that we now consider completely and utterly awful. But it's in a teaching language, so are we wrong? And this caused me to question the idea of, well, I assume certain things because my language tells me this is a good thing to do, yet other languages tell me this is a good thing to do. So I had to actually start, doing some thinking. I did it in Perl. I made that as readable as I could. And I also used the math fraction library just, because I didn't want to make it too verbose, and I thought, okay, that's quite nice. You'll see the double ellipse in there and the reverse operation. So that goes between 1 and whatever m happens to be. A nice sort of simple expressive way of saying there is a range of numbers here. Quite ahead of its time. The first line in almost every Perl program I write is the word use strict. You may recognize that. As far as I'm aware, it started with Perl. As I say, yeah, Perl was ahead of its time then. It's now behind it. Perl 6 is quite interesting, but that's weird. Some very nice things in the language, for each. That was available, 20-odd years ago. Scoped variables in the loop. Again, as someone that started learning JavaScript 20 years ago, used var and got hoisted quite a lot. The idea of actual scoping things beyond what they're supposed to was a really good thing for me here. Use of ellipses, operator overloading. So people who come from C++ and really miss that could use it in Perl. And then I thought I'd do PHP. And I found a bug. It's like, if I'm doing this, I'm doing it to sort of explore the languages, to experiment with the languages, to learn about it. It's not there, and I didn't do it so I could have a rag on the languages I didn't like. So I thought, I'm going to do Perl because I did it. I'll do C because I did that for a while. I'll do PHP, and I'll do it with a completely open mind. I won't have any prejudices. I'll go in nice, and then I get on error with the first thing I tried writing. And it's like, it's really not helping your case. And for those interested in what the bug was, the library is wrong. It doesn't return the things which are right. Oh well. But I got the right result. And then, as is me, it got very silly. I bring the ego slide up because it points out game developer, probably not completely hinged as a person, is a magician. So obviously likes sitting at home in a darkened room playing with a deck of cards. Obviously not a grown-up. So when I get silly, I get really silly, and I start programming in BASIC. Not just any BASIC, this BASIC. Sinclair Spectrum BASIC from 1982 on a computer that looked like that. What is so special about this machine, other than I owned it back in the day and I'm sort of a big retro computer fanboy? Well, it's got a very nice font. It works. Computing these few values took about 3.5 hours on an emulator with the time restrictor turned off. It was not a fast machine. But it worked, and after this point, the number system breaks down on the spectrum, so this is as far as you can go. A lot of number systems, they're written in IEEE standards, so if you're doing floating point, the numbers aren't accurate. 0.1 plus 0.2 does not equal 0.3, all that sort of thing. It's a very common problem. Spectrum had it worse than most. But I got some answers, so I was happy. Things I should point out about this version of BASIC. No local variables. Ever tried programming anything recently without a local variable, without any form of scope, as in everything is a global? Have you tried calling a function when you've got no parameters to the function, so you've got to pass them in a global, and then you've got to pass the result back out in another global? And you've got to make sure everything in your program does not reuse those same globals because they'll corrupt it. Have you ever tried that? I don't recommend it, but it's a worthwhile exercise. There was no recursion in this particular form of BASIC. I could have made things easy for myself. I could have picked a nice BASIC, like Visual Basic. Or one of the more modern, with local variables and recursion and all this kind of clever stuff. But no, I picked a version that wouldn't let me do recursion. Why recursion? To reduce a fraction, it's a recursive process, fundamentally. Unfortunately, I couldn't use recursion. See problems with global variables and so forth. So I had to rewrite my algorithm. There's no modulus operation. When you're doing this type of fractions, you need that modulus. So I had to handwrite that. And I had to use goto in order to call these functions. And 0 divided by 0, who knows what that results in? Yeah, sometimes it's 0, sometimes it's not. In various versions of these languages, 0 divided by 0 is completely at the whim of whoever happened to be sat on the machine at the time. Loops and arrays start from 1 and not 0. Another piece of standard knowledge. Nowadays, we all assume an array will start at 0. A lot of people now have been programming for longer than they have been at school, which means it's more obvious for us now to count from 0, not to count from 1. Counting from 0 gets rid of all these gate post errors. It's a brilliant thing. We just accept it as natural. But All the basics, which were meant to be an introduction programming thing, they start from 1. Fortran also starts from 1. I think Ada also starts from 1. Again, so who got it right? I did find a version of BASIC that lets you use parameters, and if you're using integer parameters, you've got to use one name, and if you've got string parameters, you have to use another. I have no idea why. And if you want some pithy little quote to tweet from this talk, was it ever really used for teaching programming or just introducing it? A number of the times I see the languages and it's this is for teaching and this is going to teach people. I was like, are you really teaching them? This isn't really programming. This is glorified rubbish. But it does introduce you to the idea of algorithms and program flow. So maybe it's not so bad. Oh yeah, I said I got silly, right? Bash. Now, for those that are lucky enough to live in a GUI world, Bash is a really nice shell language. You know, you can piece together lots of programs, take input from one program, send it to another program, send it to 2 different programs at the same time, take the output, process it, and use pipes. It's a brilliant. But it's used for chaining processes together, handling different processes. It's not meant for arithmetic. It is certainly not meant for fractions. Which means if you want to do something really ordinary and boring, such as multiplying some numbers together, this multiplies 2 numbers together. You've got multiple dollar signs, multiple different types of bracket. You've got 3 brackets in one expression. The round, the square, and the curly in one expression just to multiply numbers together. This language was obviously not meant for number processing, but you can do it. It didn't take that long, ultimately, because it's very obvious in the way that it works. But it is what, if anyone says, oh, any language that's Turing complete is perfectly good enough, just ask them what they want to build. This was not sensible. But it worked, and it was quite nice, and I was quite pleased with myself. But really, if you look at the sort of things you've got to do do that second line, jm1 equals $ bracket bracket $j minus 1 bracket bracket. That just subtracts 1. I did it in C. You'll notice I did it in C, not C++. I started C back in, well, technically I first learned of C and saw the first things in about 86, 87. I started programming in 91, and when I got my first job, they said, oh, you can program in C. Yeah, we use C++. I thought, okay. And I had not programmed C since 94, I guess. So I thought, how hard can this be? It's just C++, but, without templates. Well, I don't need templates. But it turns out I'd also forgotten if you wanted to allocate any memory, you have to call malloc. And then you have to remember to call free. I'd also forgotten you need to cast these pointers because C++ would just naturally follow into whatever it needs to do. C doesn't. I'd forgotten about having to handle pointers in this way. I would just normally use a reference. And all of a sudden, all the bad memories of C and all the things you have to do fairly simple stuff just came back and going, there's a reason I've never gone back to C. C++, for all its faults and its corner cases, is actually quite a good language for getting rid of a lot of the stuff you have to do and get wrong. Of course, it's got its own problems. So I didn't use STL or Boost because I wanted to do it raw, as I would have done a vanilla version. Struct and type defs, I'd not typed then forever. Because in C++, you can just say, oh yeah, I've got an object, I'm going to say class, object name, and it just does it automatically. So if you're ever programming in C++ and you're getting really fed up with it, just think yourself lucky it's not C. And then I went on and I did it in 20 other languages. Again, there was no particular order or structure to this. I just went through and said, oh, what do I fancy doing today? Oh, Forth. So I wrote a version in Forth, which was an incredibly difficult thing. Not because Forth is difficult, Forth is easy. And if you get bored, you can write a Forth interpreter in JavaScript in about 200 lines. It's a really simple language, it's really effective, but it's really not cut out for this kind of work. If you want to, I don't know if it is 200 lines or 220 lines or something. I released a version on my GitHub, I think, 2 years ago tomorrow. Can you guess what it was called? Released tomorrow? That's May the 4th, so I called it Jedi 4th. Okay, I'll stick to the magic and not the comedy. Point taken. So, after all of this, I'd been playing with all these little languages, doing all these little things. And I like to think that I came out the other end a slightly more questioning programmer, wondering about the things which I'd just taken for granted for so long, having done the same language, for the most part of the last 20 years. The balance between new and old ideas never struck. Even newer languages sometimes are thinking, maybe we should start counting from 1, not 0. Maybe we'll go back to that. Perceived wisdom. Where's the first array? It sticks around. Ada as array starting from 1. That's 1980. That's 30-odd years after, the first languages like APL, things like that. Which APL actually is an interesting point. Earlier when I was talking about the number of symbols that you have on the keyboard versus the number of symbols you need to express mathematics, APL had a different symbol for every single mathematical operation it would do. Every one. And it had a special keyboard with every single one. You'd either get it right or you'd get it completely wrong. But it's a nice formal way of introducing it. Good ideas will always get stolen eventually. Use strict, for example. I've been wanting that in JavaScript for so long. When it finally turned up, it's like, hurrah-y. The scope is still a debated matter, it seems. Everyone seems to have their own idea on, well, if it's inside a function, then surely everything inside that function should be allowed access to it. Surely that's a scope. But then there's other languages that say, well, actually, if it's inside that, then that's a separate scope. And it's not just things like closures where you can sort of break the rules of scope a little bit. Other languages have got that in as well. Can names be reused between variables and methods? I never thought it was a good idea to have a function called game and then a variable called game and another method called... But apparently some languages allow it and even encourage it. What else did I do? Transpiling, nomenclature. Yes, enumeration comprehensions. I've got no idea what I was thinking when I wrote that, but never mind. Oh yes, nomenclature. Language is a fantastic invention. It is the invention that makes all others possible. That's my quote, by the way, honestly. It's not someone else who's more famous and talented. But you'd think by now, after doing this software engineering malarkey for years and years, we would have a nice standard nomenclature where everything would have a most obvious name that everyone could agree. Enumerations, for example. A fairly obvious name. It exists in C and C++ as the enum keyword, so it's fairly obvious what you're doing. Enum, that's an enumeration. Yet some languages come along and says, oh, right, we see you've got 20-odd languages that already use the word enumeration. We're going to implement exactly the same thing in exactly the same way, but we'll call it comprehensions. Which just makes it that slightly more difficult. That raises the bar slightly for you to get into it, because all of a sudden it's like, what's a comprehension? Oh, it's something I already know. So why don't they call it that? Transpiling is looking to be an interesting area for me about doing this as a little project thing. And some languages, I think, have just been intended as a patch language. Now, what I mean by that is it's not intended to be the next great leap forward. It's just meant to stop us of suffering the pain of right now. So we had a little chat last night. Who here remembers Subversion? Yeah, quite a few of you. Oh, you're not quite so young. Who remembers CVS? Oh, okay. Now we're narrowing the herd a little bit. And what about CCS? Oh, just the... You and me both, pal. So why did I bring this up? Well, CVS is a versioning control system, just like Git and Subversion and everything else, and it's not bad, but it's not great. It was fine for the 1970s and 80s. Git was obviously the thing that we wanted to go towards. We wanted distributed source control. But in order to get there, we couldn't just jump from CVS to Git. There'd be no way of doing it. The mindset wasn't there wasn't experience, and there wasn't the tools to do it. And the reason that there weren't the tools to do it, because all source control was in CVS, and it just wasn't good enough to build that type of software. So SVN was created. When they built it, they knew it was never going to be the last word in source control. But it was a very good piece of software, and it caused us to move away from CVS to something better, so we could then go on to distributed, such as Git. So in that sense, Subversion is a very good patch to the source control problem. The same way as some languages seem like they're patching between, well, it's better than what we had, but it's not what I really envisaged a programming language to be like. Something I found on a personal level, I also adapted to the old coding styles. So obviously all these old programming languages I worked at through various points in my life, I would naturally put the brackets or the begin and the end exactly where I did 20 years ago without thinking about it. It's like a muscle memory. All of a sudden, I fired up the editor that I used to use, and it's like, oh, right, I remember I've got to hit F2 here, and then this control, and then that. And it's like, how come my brain has recalled the key shortcuts for an editor I've not used in 20 years, but I can't remember what I had for breakfast yesterday? And algorithm improves as the realization sets in. So obviously, I started with quite a banal brute force kind of algorithm. As I was implementing it over and over again, my wording for the variable names changed and improved. My understanding of the algorithm naturally improved. So I said, well, actually, I don't really need to compute this bit because it's not really used again. It just makes the algorithm look nice. So I just got rid of it. And that was quite interesting. And naming things is still very hard. I still have not decided on a set of variable names for that 20-line program that I actually like. So that code, by the way, is also available in ActionScript. Anyone still did that? Yes. Well, more than I thought. That's good. Bolt you won't have done, unlikely. That's a programming language I built for kids. CoffeeScript, there's probably a few in here. No, not so many as I thought. Crystal, Forth, Fortran, Go, Java, Lisp, Lua, Python, Ruby, and there's probably some others. So that's me all done. Normally this is when speakers plug their books, but I can't be bothered. They cost 20 quid, and the amount of royalties I get from them is so small, you might as well just buy me a pint, and I'll tell you everything that's in them. How's that for a deal? In fact, buy me 2 pints, I'll come round to your house and read it for you. So my name's Steve, also known as Marquis. Thank you very much.